Alrighty, welcome everyone to day 7. Today's problem is going to be reusing our IntCode program, which I've already copied back over here and made a small tweak. But for today's problem, we are given a series of 5 amplifiers, and each amplifier is running our IntCode program that we've already wrote. All the amplifiers are in series with each other, and we are giving one input to amplifier A. That output of amplifier A goes to amplifier B. The output of amplifier B goes to the input of amplifier C. Amplifier is a really hard word to say, but you get the point. So the input goes through A to B to C to D to E, and then after E we get the output of our answer. The answer, though, is we are trying to find the largest output signal that E can send, which goes to the thrusters. So on top of all that, each amplifier has a certain phase setting, a number from 0 to 4. However, in that series, each thruster has to have a unique phase setting. So we have 0 through 4, so one of them has to have 0, one has to have 1, 2, 3, and 4. They can't share the same phase setting. It is unique to all 5 of them. So given that, we have to we have our interpreter already for encode. We need to use this to run the 5 programs on each of the amplifiers and find their corresponding phase settings that create the largest output. So currently when we run the IntCode program, it asks for 2 inputs. The first input is the amplifier's phase setting, and the second input is the input signal. So for A, it starts at 0, but for B, it'll be whatever we get from the output of A. So let's go ahead and run this. I've already set up a for loop here to make this run 5 times. So the first input will be the phase setting. So let's just do 0 as an example. We get 0 as our input. The output's 92. So the phase setting for this one will be 1. Input will be 92. We get 1868, sorry, out. Let's do a phase of 2. Input of 1868. That's our output. 3 phase, 14988 as the input. And then lastly, 4 is the phase, and 44968 as the inputs. And this is what we would get. So the goal of this is to adjust our encode program, our encode interpreter code here, to, instead of outputting like this, to grab the output, put it as the input, and find the correct phase settings to give us the highest output. So the first thing I'm going to do is up here, I'm going to put in all the different possible phase settings. This is definitely not the most ideal way to do it, but I can't think of a better way to do it at the moment, and this I know just will work. Okay, so we're going to generate the combination. So we just want to do let's just hard code instead of just I think I'm trying to get too excessive with this. Let's do 5 for loops. I J K L and M. So 5 for loops. And then M. And so at each level, we need to check if I equals J, continue. However, at this level, we need to check if I equals K, or J equals K, I equals L, or J equals L, or K equals L, Again, this is not the most efficient way to do it. But actually, this is only one number. But whatever, just keep this all the same. M, 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 L equals M. Okay. Fine. And then what we can do down here is just do phase settings, add new integer, and then do I, J, K, L, M. Integer. There we go. There, so now this will generate all the combinations, and we can do system.out.println arrays toString, and just copy this in here. Again, probably not the most efficient way, but this just works, and I've been struggling with this for a little too long, so I'm just gonna kind of run with it. Okay, so let me run this. And a quick look through, that all looks right to me. Okay. Actually, ends it correctly. Okay. So that all works. So let me go ahead and remove this. So now that we have all of the phase settings, we can simply go through all of these, and we can do then for integer phase in phase settings. We can do another for loop around this whole encode program here. And then what we can do is phases. We can use this as our input. So we'll go ahead and override this input here. Oh, we need to know which one it's asking for. So let's do a Boolean phase input. True, it asks for the phase input first. So we're gonna edit this to, instead of doing it this way, we're gonna do if phase inputs we have input equals 0, no more scanner. So phase input equals phases I. Or phases J, sorry, phases J. Otherwise, we are asking for the total inputs, which I haven't calculated yet. Int total 0, so now we will be giving it total. There, and no matter what we do here, we need to flip phase input so that the other gets triggered the next time through. Okay. And then when we go to output, instead of outputting here, we're going to do total equals whatever this is output as. And then this system out will be at the very end after we've gone through all the phases. You'll system out total. Fingers crossed this works. We get a really large number. Oh, wait a minute, wait. My bad. Total goes in here. And we need int largest total here, because we have to compare it. We need to find the largest total that each phase gets. Okay, so down here after this, we need to do if total is greater than largest total equals total. Might have initialized. We're going to initialize it to 0. Now we run this. Now we should not get a negative number, so we shouldn't wrap around. Good. Enter this as our input. And we got it right. Let's go. Part 1 down. On to part 2. Hopefully this time I don't stall out literally on just creating a combination map. That was a little easy and I spent way too much time on that. But anyways, part 2. Let me read it and I'll get back to you guys. Okay, so I'm back with part 2. I originally started part 2, did it for about an hour and got nowhere. I then had some real life obligations I had to go to, but I'm back now. It's much later in the day. So I'm going to attempt this again. I still don't fully know how I'm going to make this work. But, so for part 2, we left off with the amplifiers basically being in a series. The output of one was chained to the input of the next, and then output of that one was chained to the input of the next one, and so on and so forth. Part 2 is that we are now feeding back amplifier E, which is the last one, back to amplifier A, because the amplification from all of them was not enough. So that's where we left off. The issue I was having when I first attempted this is my Intcode programs can't be stopped outside of a halt. So the new way that they're going to work in part 2 is that whenever there's an output from one of the amps, you have to stop the program, take that output, feed it to the next input, and then start that next one's code based upon that. That is where the issue is occurring right now. So I am going to try and figure this out. So we have all our Intcode programs. So I'm going to attempt to make this Intcode program class I have here. That is going to take all of this. And it's going to be in the execute method. And then all of this part will be at the very top out here. Make them all private. Okay. So what are we missing? So we're missing private integer list. This is the program. Okay. We need to create a constructor for this class. It needs to take in the program. This dot program list equals program list. Okay, and then we also need this method helper down here. Not there. Go down here. Okay, so there we go. So there's all that. So now we're just down to basically the changes we made in part 1. These are the changes we made here. So we have execute here. So I wonder, what if we take all of this and put it into a step function? So public void step. And then basically this just calls step. Okay. So now in input, what if we make a method here? So public void set input. Okay. And so we need input to be an integer. So private int input. Okay. All right. So what we're going to do here is we have this case. So this case is where the input is going to come from. So what we can do is when we get to input, stop the run. And move this down to here. So this is going to be int input. So actually this is all going to come out of here. Let me just put this in here for right now, but comment it out. So here's the input. So we'll set the input. We're going to make a variable up here. Actually, so instead of input here, we're going to make this a Boolean called waiting for input. Set this to false. We're going to move waiting for input down to here. So run is false, waiting for input is now true. And then when we set the input, we're going to make sure that it is waiting for an input. If it is, we will then set it to false. And we also will now set run to true. And okay. All right, I think that's good. Actually, I don't think we need the step here. I think I don't. Yeah, I was thinking about a possible solution, but I don't think we're gonna need step for what I'm gonna go for. Okay, and then we also need we need two variables. Boolean is halted. This is gonna go right up in front of run. So is halted. We will put this here. So now you can only execute while. Oh, do you move? Oh, you remove the while. So while run and not halted. This will prevent us from running it when we don't want to. Okay. And then we also need one for, actually this is gonna be public int last output. And we're gonna use this here. I think we can get away with this. Okay. So we have all the phases. So these are all the phases. So we need our int code programs. So we're going to do int code program programs equals new int code program. It's going to be a total of 5 of them. And just like this, however, it's going to be program reset. This is actually going to be somewhere else, but we're going to do programs I equals new int code program. Oops, sorry, this way. And this is going to be program reset. Okay. So this actually needs to be moved into here for the phases. Get rid of that. Okay. So each time we go through here, so J is going to be the current program we want. So int code program, current program, fixable current, right? Current program is going to be equal to the program's J. I'll do this again here. Actually, we don't really need this. Oh, we do need this because we need to cache our programs, right? So this is actually not going to be a for loop. This is going to be while program for is halted method in here to know if the program is halted. Public Boolean is halted. Return is halted. Program for programs for is halted. So while the fourth program is not halted, run through all these. So we're going to do int j equals 0. This is how we're going to count up j plus plus, and current program is programs j. Okay.
So what we're going to do is we're going to call execute. We're going to need one more Boolean array here, because this is going to be, oh, I removed this code in here. It's okay, because I have it on my GitHub. It's already pushed the part 1 for day 7 of code. Okay, so this is going to be the phase inputs. It's a new Boolean array, size 5. Let's do phase input starts. Phase input starts as true. So true, because phase input's the first thing. And then after that, it's only, okay. Okay. So there's phase inputs. So we are going to start, we're going to go through all of them. So the current program, we're going to check current program. We need to know if it's waiting for inputs. Public is waiting for inputs. Thank you, IntelliJ, for completing that for me. I should put this up here. If the program is waiting for input, if it is, we should supply it. And we're into supply it, we are going to use what we had here. And so this is actually going to be phase inputs J. If it's true, we only put the phase in once. So now it's going to be equal to false. And we're going to do current program dot set inputs equal to phases J. Correct and good there. On the other hand, we don't need that. The input is going to be the total, but it's coming from the previous one. So int last program equals J minus 1. If the last program equals -1, last program equals 4, that way we can, it will wrap around, and we will just do this and programs last program last output. I think that's what we want. Okay, so that's gonna be waiting for input. And what we then do is we will call current program execute, because now it should be able to execute again. And then after, we will check if current program dot is waiting for input. So now if the current program is waiting for input again, or I guess if this didn't run and now executed, now it is waiting for input. That means it's looped, or it's looped to a point, or current program dot is halted one way or the other. That means it's waiting, or is finished running. That means to pass off to the next one. So we will do J++ there. Actually, it's not really necessary. We will just do that. So now we gotta set total. Actually, so total is actually not that anymore. Total is actually going to be programs for dot last output. And let's give that a try. I have no idea how this is going to go. It's probably going to go terribly. All right, next out of bounds exception. Okay, that's fine. We need to reset J back to 0 if it goes over. Right, okay. It's running. It's infinite looping. Okay. I like infinite loops. All right. Let me see here. How do we get to run being false and also halt code? Because run is, oh, here. Never mind. Output, don't stop running. Don't stop running when we output. Never mind. There's the issue. Let's try that. There's an answer. No. It's too low. Wait, was that the answer to the previous question? Yeah, that was the answer to the previous question. Okay. That's fine. So that means we're not feeding back into the system. We're not feeding back into the system because I forgot to change these. I forgot to mention about the question is that the phases are not 0 through 4. For part 2, the phases are 5 to 9. So it's actually 5 to 10. So that's my bad. Okay. Now let's give this a run. We got a different answer this time. We submit it. Please be right. Oh, I gotta wait for 10 seconds. Hold on. I swear. Please, please be right. I'll be so happy if I came back and got this in 20 minutes. I got it right. Okay. You know how happy I am that I came back, literally solved this in 20 minutes when I spent an hour plus the first time. So that's actually not... it actually is a decent system. Yeah, the whole... Yeah. So in theory, though, we could re-implement this to work with all the rest of them, but either way, yeah. All right, so to summarize, I kind of forget part 1, but to summarize, so the first part was in a series of amplifiers, so a series of 5 of our encode programs. We had to take the outputs of the first one, feed it into the input of the second one, output of the second one was the input of the third, so on and so forth. And so we feeded it 0 as the very first input, and we took the output from the 5th one, and we tried to find the phase, so that was a second input to all of the encode programs. We tried to find the combination of phases that produced the highest output. And then for the second problem, we took our basic existing encode program, had to make a few changes to it to allow for halting the program on an input and just holding it there until we were able to eventually give it an input down the line. So this has been a very hectic day for me because I've had to stop and I kind of forgot the work I did, but hopefully you guys enjoyed. Hopefully the video still turns out all right, and I will see you guys all tomorrow for day 8.